Hello everyone, this is Neil from Edureka and welcome to today's session on Java training. Now without wasting any time, let's move forward and look at today's agenda. Now we'll start off first with an introduction to Java and then we'll be looking at the timeline of Java, how Java has grown over the years. After that we'll be discussing the various features of Java and we'll understand how the Java environment works. After that, we'll be discussing on how a Java program works as well as how a Java code is executed in a real-time scenario. Then we'll deep dive into Java by discussing the various data types, the operators as well as the functions present in Java. Finally, towards the last half of this session, we'll be talking about the object-oriented concepts in Java. So are you clear with today's agenda, guys? Okay, so Adam is clear, so is Mayank, Anjali, Kripa, Aaron, Vivek. That's great to see, guys. Okay, so Vivek is asking me, will there be any practicals as part of today's session? Definitely, Vivek. So when we'll be discussing each concepts, we will be working them out practically as well. Is that clear, Vivek? All right. So now let's move forward into the first topic, that is the introduction to Java. Now, Java was created by a team led by James Gosselin in 1995 for Sun Microsystems. Now, the main reason that Java was created was when they were working on a project for digital media back in 1995, they felt that coding with C was not very reliable for a digital environment, that is your home system. So what they did, they went ahead and created a new programming language known as Java. Now, the first alpha and beta versions were released in 1995 and the official version Java 1 was released on 23rd Jan of 1996. Now, when Java came out in 1996, not only was it a programming language, but it also provided a virtual platform for Java applications to run. Now, this virtual platform could be present inside any device. Now, Java has grown over the years, but this virtual platform that Java provides is one of the key features that has led to the constant growth of Java in the industry. Now, Java is not only a programming language, but it's also a platform for Java applications to run. Now, there are mainly three key features Java as a programming language follows. The first is the concurrency. Now, let's say you have certain sequences of operation that you wish to perform. Now, in other programming languages that follow a procedural oriented approach, what happens is these statements gets executed one after the other. But let's say these statements are not dependent on each other, then in Java you can concurrently run these operations and make your program faster as well as more efficient. Apart from that, Java is also a class-based programming language. Now when I talk about class-based programming language, what I mean is that every code that you're going to be writing as part of a Java program is going to be written inside a class. Now, don't worry about what is a class. We'll be discussing extensively about class as well as the object concept in the later part of this session. Apart from that, Java is also an object-oriented programming language. That is, it strictly follows the concepts of object-oriented programming language as well as it considers everything to be an object. So the operations that you will be performing also will in turn be with respect to objects itself. Now, one of the key features that Java offered when it initially came out in 1995 was the logic of write once and run anywhere. Now, what do I mean by write once and run anywhere is that once you have written your code, then you can run it anywhere where the Java environment is present. Now, this could be a simple device like your dish TV, like your set-top box, or it could be a complex device like a scientific computation system. So once you have written your Java code, it will simultaneously be able to execute on both these environments as well. So your Java does not depend on the configuration of the system on which you're running the application. Your program will be scalable to meet the hardware requirements that are present in these devices. So with this, I hope you guys have a clear introduction to Java. Now let's move forward and discuss the timeline of Java, that is how Java has grown over the years. Now, when we talk about the Java timeline, so basically there were 9 versions of Java that was released over the span of the last 22 years since Java officially came out. Now, I'll be using some of the key terms here. Now, don't worry if you're not quite familiar with them or you're not clear with respect to what they are. You will be learning each of these key terms as part of our training. Apart from that, I'll also be giving you a documentation with respect to the changes in these versions as such. So, as I had mentioned earlier, in case if you're preparing for a Java interview questions where they do ask you with respect to the change in the versions, you can always use this document for your learning purpose. We'll start off the first version that was known as Oak. Now that was the actual name that was suggested for Java, but then since that name was taken, it was changed to Java. That was the favorite coffee of the programmers that time. Now your Java Oak version 1.1 mainly concentrated with respect to a basic application building that is using Java as well as your access specifiers. Now access specifiers is a key concept that we will be discussing as part of our session later today, but keep this in mind and we will be extensively discussing that in our later part of the session. Now after that you had Java version 1.1 that was released. Now this version mainly concentrated with respect to your database connectivity as well as your RMI. Now RMI stands for remote method invocation. Now what we mean by RMI is that if there are certain dependencies that your Java program needs, then if it's connected over a network or if there's another device that is there on the local system which has these dependencies, then you can take the dependencies from that rather than having them already as part of your current environment. So this highly improves your memory efficiency as well. Then you had version 1.2 released in December 1998 known as Playground, and this completely focused with respect to your JIT, that is just-in-time compiler, as well as your collection framework. Now Java uses both a compiler as well as an interpreter. Now this is mainly because every time that you write a code, first it's going to be translated to a bytecode, and this is something that is done by the compiler. Now bytecode basically is an intermediate file that you get before you go ahead and execute the program. Now through bytecode, Java attains both scalability as well as security feature, and I'll also be showing you what a bytecode looks like as part of our session today. Now once you have got the bytecode, your interpreter actually converts this to a machine code just before you're going to execute this program. And that is one of the key reasons why you have both the compiler as well as the interpreter present in your Java environment. Then coming down to collection frameworks, what Java developers saw was that there was a constant set of classes as well as interfaces that were usually used together. So what they did was that they combined all these classes and interfaces to a collection. So rather than importing these long list of classes and interfaces, they just had to call a collection, which made it quite easier for them also to code the program. Now coming down to the next version, that is version 1.3 known as Kestrel. This mainly focused with respect to your Java archives, better known as jar files. And then you had version 1.4 known as Merlin. Now this extensively concentrated with respect to your XML files. Now XML file processing as well as file handling is something that we will be discussing as part of our 8th module in our training session. Then you had the version 5, better known as Tiger, which concentrated mainly with respect to your boxing as well as unboxing concept, as well as a key term that is generics. Following that, you had version 6, which is known as Mustang, which concentrated mainly on annotations on your Java servlets, that was web development. Now after that came your Java 7 known as Dolphin. Now this is something that is a standard version that is used by most of the industry experts presently, but still most of them are already migrating to the next version, that is Java 8. Now this version extensively concentrated with respect to your exceptional handling as well as the optimization of the codes that you would be writing in Java. So if someone asks you which is the standard version that is used across in the industry, then there's no right answer as such, because there is a group that uses Java 7 as well as Java 8 as such. So we will be working with respect to Java 8. So don't worry, if you have any applications that is written in Java 7 as well, it will definitely run on your Java 8 environment. Then came your final version, that is the latest version Java 8, that concentrated with respect to your Lambda expressions, which made it easy for you to write generic programs. Now, Lambda expressions is also another key feature that we'll be discussing in the later part of this training. Now, there's another version of Java that is coming out later in July of this year, that is 2017, that is known as Java 9. Now, that mainly concentrates across your modular programming concepts. Now, don't worry about that. For now, you need to mainly concentrate with respect to Java 7 and Java 8. We'll be covering a course across with respect to Java 8 itself. So, any questions still here? Okay, so Anjali is asking me, is there any other programming style apart from object-oriented programming style? Definitely, that's really good question, Anjali. I actually missed out on your question in the previous slide. So apart from object-oriented programming style, another popular programming style is your procedural programming style. Now, to help you understand how both work, let's compare both. Now, in your procedural programming style, what happens is that you follow a top-down approach. That is, your code gets processed in a sequential order starting from the top and goes all the way down. But when you look at object-oriented programming style, it follows a bottom-up approach, but the flow varies with respect to how the flow of the program changes. Now, apart from that, one of the key reasons why they both are different is that in your procedural oriented programming style, the main focus is across the sequence of operations that you're following. But when you look at the object oriented programming style, your focus is on the data rather than the procedure or the sequence of operations. And to give you a few examples with respect to both procedural oriented programming style, you have your C, you have Fortran, Pascal, your Visual Basics, but at the same time when you look at object oriented programming style, you have C++ as well as Java and Visual Basics .NET as well. So I hope with this you are clear with respect to the two different programming styles and how they are different. Now, there are mainly three editions of Java that are available today in the industry. You have your Java standard version. Now this is a basic core version of Java through which you will be performing all your development operations. After that you have your Java Enterprise Edition. Now this is something that you will be using while you're developing and deploying applications on a large scale. So we will be working across with respect to the Java Enterprise Edition itself as part of our training. So here key concepts like XML file handling, your Java servlets, your Java server programming pages, as well as we're working with different frameworks, all this comes under your Java Enterprise Edition. Now finally, the third version that you have with respect to Java is the Java Micro Edition. Now this is something that runs across your mobile phones as well as your set-top boxes. So small scale devices that use Java are mainly considered in your Java Micro Edition. So with this, we actually come to a conclusion to the introduction of Java, and we'll be moving across to the next topic, that is features of Java. Now, there are mainly 8 key features of Java that we'll be extensively discussing, and these key features are also called as buzzwords of Java. You have simple, portable, object-oriented, secure, distributed, dynamic, robust, and high performance. Now, the reason that these keywords are quite popular was that when James Gosselin and his team had completed the development of the Java programming language, what they did was that they submitted a white paper. And in the white paper, these were the keywords that were completely highlighted as features of Java. And that is one of the key reasons that they are very popular as such. So we'll be discussing about each of these key features in detail. Let's begin with the simple keyword. Now, Java is one of the most simplest programming language that you can pick up. So as I had mentioned earlier, even if you do not have any exposure to programming language or you're not familiar with respect to object-oriented programming language itself, even then you would not have a problem in learning Java as such. So again, coming back to what I had mentioned earlier, if you are familiar with respect to object-oriented programming style, then I would definitely recommend you to not compare Java with the programming language that you're familiar with. This could be C or it could be Visual Basics or Pascal. But so if you try to compare both, you end up being confused with respect to both. So it is always better to have a complete and a clean mind before you start learning Java. Now, the next feature of Java is its portability. Now again, we can go back to the principle that is write once and run anywhere. So once you have written your code, it can be executed across any system as such. Now this system could have any of the various operating systems that are available today in the industry, and it could have any specific configuration as such. Your Java program will scale across this hardware and software to meet its requirements. So you don't need to worry whether the Java application will be able to run in your hardware as such. Then we are all familiar with respect to the object-oriented concept. So Java is one of the few programming languages that is considered to be a true object-oriented programming language. Everything in Java, as we have already discussed, is considered to be an object, and every operation that you'll be performing as well will be using objects as such. Then you come to the secure feature of Java. Now the key reason Java is considered to be secure is that now the Java application that is going to be running in your virtual environment is present inside a sandbox. Now this sandbox actually prevents the Java application from directly interacting to your hardware, as well as any other application that is running on your hardware to directly interact and corrupt your Java application running in that sandbox. So basically it's a two-way security that works. Apart from that, Java does not use explicit pointers. So if you've learned C or C++, this is one of the key concepts that I always felt irritating, that was working with pointers. So in Java, you don't need to worry about pointers as well as memory management as such. This is something that is extensively taken care by Java itself. So you don't need to worry whether a Java application would work with your system memory and overwrite any existing values. Your application completely runs on Java, which takes care with respect to memory management. Okay, so Scott has a question here. How does pointers violate security? Now this is a really good question, Scott. Now, when you're working with pointers, what you basically do is that you actually define the memory location where you want to store your variables. Now, this could be basically an abstract location where you're storing a value. Now, sometimes what happens is that memory location is also be going to be used by different applications. And this memory location that you're using in your system may not be the same that is going to be used in someone else's system. In Java, what happens is that the complete memory management itself is taken care by Java itself. So there's no abstract jump, or there's not going to be any violation of the memory management as such. So I hope with this you're clear, Scott. All right. So moving forward, the next feature that we're going to be discussing is the distributed feature. Now, your Java applications once written can be distributed to any device that supports your Java virtual machine. Now, again, as we have discussed, the remote method invocation helps your application to invoke a method of another program that is present either in your network or it's connected through the internet as such. And then once it's got its output, it can go ahead and process its data. So remote method invocation is one of the key features that Java became popular in the late 90s as well. Now following that, you have the dynamic feature of Java. Now Java is a highly dynamic programming language because it has a substantial amount of runtime information. Now what I mean by runtime information is that only before you execute your Java program does it take its corresponding values. That is, it starts allocating memory, it starts identifying what kind of system are you using. All this information comes in just before you run the application. Therefore, it starts scaling only before you run your application as such. So it's a highly dynamic programming language. Then comes your robust feature. Now, Java checks your code once after compiling your code as well as once before you run your code as well. Now this is mainly to ensure that no one has tampered or made any corrections with respect to the code that you have created. Apart from that, again, your memory allocation comes here. Java completely takes care of your memory allocation as well as your memory releasing as process. So you have an extensive process known as garbage collection that we'll be discussing in our third session. Now, Java achieves high performance through the use of bytecode. Now, once you have your bytecode, that is your Java code gets compiled and converted to the bytecode, then you can run it across any machine that has a Java environment present in this. Now, once you're executing this code, the code in turn scales as to meet the system requirements and achieves high performance through this. So with this, we have come to a conclusion with respect to the features of Java. Any questions with respect to any of the features, or you're not clear with respect to any of them that you want me to repeat? Okay, so Adam is clear, so is Scott, Anjali, Kripa, Vivek, Mayank. That's great to see, guys. So one thing I'd like to put across is that at any point, if you're not clear or if you want me to repeat any concepts as such, please put it across in your chat box so that I can clarify it then and there itself. I do not want you guys to have any questions and then carry forward it post this session. All right? Okay. So moving forward, let's move into the next concept, that is the Java environment. So we've talked extensively about the Java environment, how it helps you to run a Java application, but you may still not be clear with respect to how the Java environment works or what exactly the Java environment is. Now there are mainly three key elements that you need to be aware of when you're working with respect to your Java environment. Now the first element is your Java virtual environment. So this is basically an abstract machine in which you're going to be running your Java application. So this virtual environment can be present across any device. It could be your mobile phone, it could be your set-top box, it could even be a high performance computer as well. So always your Java code is executed inside your Java virtual machine. So this is the bare minimum requirement that you need to have when you're running a Java application. After that comes your Java runtime environment. So this is actually a real-time environment in which your Java virtual machine is also included. Apart from that, your classes and libraries are also included. That is, the dependent classes and libraries, everything would be present in your Java runtime environment. So this is something that you mainly see across your computers as well as your strong hardware devices. Then comes our major and main element, that is your Java development kit. So this is basically a toolkit that comprises of both your Java runtime environment and Java virtual machine, apart from some development tools. Now, for us to work as well as create applications, we need the Java development kit present on our system. So I hope with this you guys have got a simple introduction to how the Java environment works. Okay, so Adam is asking me a question. By default, which Java environment is present on our system? Now, again, Adam, it actually depends on what kind of device that you're using. Now, if it's a simple device, it will have a Java virtual machine. But if you take in case of your computer or laptop as such, you will have the Java runtime environment present there. So we actually need to download and install the Java development kit. So in case you've not extensively downloaded and installed the Java development kit, it won't be present in your system, but we will be doing that in our upcoming slides. So moving forward, let's go to the next topic, that is how does your Java application work? Now, so once you have written your Java code, that is you'll be storing it in a file with having an extension of .java. Then what you're going to do is that you're going to go ahead and give it to your Java C compiler. So your Java C compiler, what it does is that it checks if there are any errors present in your code, and if there are no errors, then it goes ahead and creates a Java bytecode file. Now this file actually has an extension of .class and is not something that you can directly read and understand the code. And then you get your Java bytecode. Now this is basically the intermediate file that we had discussed about. So once you have your Java bytecode, this can be given across to anyone who wishes to run your program. Now, when they have to run the program, it goes to their Java virtual machine where the Java interpreter as well as your JIT compiler processes this file and then goes ahead and gives you an object code. Now your object code mainly consists of code that is written in your machine level language. That is, your Java code gets translated to the machine level instructions. Once that is done, then it goes ahead and processes information so that you can get your output on your screen. So are you guys clear with respect to the life cycle of how a Java program works? Alright, so I've got a confirmation from everyone. So let's move forward and begin with the installation of Java in your system. So as I had discussed, we are going to go ahead and install the Java development kit on your system first. To do that, all you need to do is that you need to go to Google and search for JDK download. So that will redirect you to Oracle's Java delivery page. So here you can download the Java development kit. So let me show you how it's done. So just open your browser and search for JDK download. Now just open the first link that you see here. So you have two options here. You have Java development kit as well as NetBeans with JDK. So go ahead and download JDK option here. So just click on download and then here select the option to accept the license agreement, and then you can choose the corresponding version according to your system configuration. So go ahead and download this file, and once you have completed the extraction, it's a simple installation process. All you need to do is just click on next, next, next. So in case if you're facing any troubles, do let me know. Alright, so now that all of you have gone ahead and installed Java on your system, there's another step that you need to follow, that is the setting of Java path in your system. Now let me show you how to do that as well. So just open your My Computers, right click and go to Properties option here. So here to the left you have this option that is Advanced System Settings. Just click on that and you will get a pop-up with the Advanced System Properties. So go to the Advanced tab here, make sure you're on this tab and you have this option known as Environment Variables. So just click on that, and here if you do not have a variable known as path, then you need to go to New, Add Path, and then you need to specify the variable value. Now this is basically the location of your bin folder of your Java development kit. Now if you have not changed the default installation location of Java development kit, then you can go inside C folder, go to your program files, you have Java, go inside the JDK folder, not JRE folder. Here go inside bin and then take the complete path here. So make sure you're taking the path of bin folder from the JDK file. Go back to your path variable and here you need to specify the value. Once you've done that, just click on OK. Since I've already set it, I'm not going to change it. And in case if you already have the value present there, then just click on Edit, go all the way till the end, put a semicolon, and then put the path value. So please follow this step. In case if any of you are facing the trouble, do let me know. And there's a final check that you can perform if your Java path has set. Just run your command prompt and type Java C. Now, if you type that, you can see the various operations to check for Java C. Now in case if you're getting these options, then you have completely configured the Java path But if you're not getting these options, do let me know so that I'll be able to assist you in the debugging process. Okay, so now that most of you have gone ahead and completely configured your system with respect to Java, let me show you how to write a simple program in Java. So here always start with class, then let's call it hello, open parenthesis, and always make sure to put a closing parenthesis wherever you have started. Now here, the first thing that you need to write is that you need to write a main function. The main function is the point where your code execution begins. So the syntax for writing the main function is that public static void main, open parenthesis, then you have string args, again open curly braces. Now this is the standard format for writing a main function, and your main function has to be part of your class. So these two things are must. Your Java program should always have a class and your main function should be present inside the class. Also, one more thing that you need to remember is that the name of the file should be the same as the class that has your main function. So in future you will be using different classes as part of your program. So at that time, whichever class has your main function, the name of the file should be the same as that class. So then comes your command to print. So the syntax for printing anything in Java is system.out.println. So here we're going to be printing hello world. Okay, so it's time you save this code. Always make sure while you're saving the code it has an extension of .java. Okay, so just save it. Now it's time to compile this Java code. So again you need to run your command prompt. Here you need to go to the location where you have stored the Java file. Now this is the location where my Java file is present. So let me show you this location. So let me go inside C Java folder and you can see hello.java. So this is my Java source code file. So now what I need to do is that I need to compile this code first. So the syntax for compiling a code is java c space the file name hello, and don't forget to give the extension of the file .java. Now the syntax for executing a Java program is java c then your Java file name. So I had saved it as hello.java. If you're given that, so you can see here there's an error that has come. So if you go inside the code, so you can see here instead of giving println, I had given print d, ld. So you need to correct that, make it println, save the code, go back to your compiler. This is how you identify if there's any error present in your code. So let me just rerun the command again. So you can see I have a blank terminal here. So this means that it has successfully compiled my code. Now if you go inside your folder, there you can see a new file has been created, that is hello.class. So this basically is your bytecode. Now if you want to see what a bytecode looks like, let me open it. Here you can see how my source file has been converted to bytecode. Now this is not something from which you can translate and identify what I have written in my code. So it becomes highly impossible for you to identify what is part of my code as such. So always your bytecode is going to have an extension of .class. And finally, to execute your Java code, you just need to say Java and then you need to give the file name, that is hello. So here you don't need to give the extension. See, I have executed my code and it's printing hello world. So I hope with this you guys have a simple idea on how to write your first program in Java. Okay, now when you're writing few thousand lines of code, it becomes problematic while you're writing it on a text editor. So I had actually used Notepad++. So instead of doing that, what we're going to do is that we're going to install an IDE on our system, and the IDE that we're going to install is Eclipse. Now Eclipse is a standardized IDE that is used widely across the industry. So we're going to download and install Eclipse on our system. Now to do that, all you need to do is go to Eclipse website. So this is the Eclipse website, and here you have the option of download. So just click on the download option. So here you can see you have the option of Eclipse Neon download. So just click on the option here. Now go to download packages option. So Neon is the present version of Eclipse that we're going to be working with. So here on this page, what we need to download is we need to download the Eclipse IDE for J2EE developers. So there are different versions here and we're going to use this J2EE version of it. So go inside this. So here you have the download links for that. So this basically is going to give you a zip file. So you can choose your corresponding system configuration and download the corresponding file. Now, once you have downloaded the zip file, all you need to do is directly extract it, inside which your Eclipse IDE would be present. And then you can go ahead and launch your Eclipse IDE. So let me launch the Eclipse IDE I have on my system. So let me launch Eclipse Neon. So first you need to specify the workspace. Once you have specified the workspace, all the projects as well as the code that you'll be working with will be stored inside your workspace. Click on OK. So the first thing that we're going to do is that we're going to begin by creating a new project. So to do that, you have this new option here. Just click on it and create a Java project file. So let me name it Java Training and then just click on Finish. So you have your Java Training folder here, inside which by default you can see source as well as your JRE system library. So this system library has the complete classes that you wish to use in your Java program. So right click on source once again and then go to the new option. Here click on class. So we have already discussed that every code that you're going to be writing is going to be present inside a class. So let me just rename it as hello and then click on finish. So here you have your hello code. Now you can see here by default while I was creating the class itself, I had included the option of main function. So it has already given me a public static void main. Now here I need to write the system. Here you can write your print statement, that is system.out.println. Now you can either completely write the statement or what you can do is that you can write sysout and then press Ctrl plus space. This is a shortcut that translates your sysout statement to system.out.println. Here you can just write hello world. So then just go ahead and save it by pressing Ctrl S. Now it's time to execute this code. So right click on the workspace and then go to the run as option. So here just click on Java application option. Once you do that, your code gets executed and you can see the output of the code, that is hello world. So I hope with this you guys are clear on how easy it is to code using an IDE. So any questions with respect to the program that we have written or how to use Eclipse? Okay, so I want you guys to go ahead and write the same program and then let me know in case if you're facing any troubles. Okay, so now that you have all successfully executed the first program in Java, what we're going to discuss is the structure of a simple Java code. So there's a simple structure that you need to always follow. So the first thing that you need to specify as part of your Java code is to specify the package details. That is, if you're using any package or collection as part of your program, then you need to specify that. After that comes your class. So we've already seen how to define a class, and if the class has any specific data members associated with it, you're going to display that. Then if there's any specific function that the class has to perform, then you're going to write that, and then finally you're going to have your main function. So always your execution starts from the main function, and then depending on which function or which member it refers to, the flow changes accordingly. So I hope with this you have a clear idea of the structure of Java program. Okay, Kripa is asking me what is a function. That's a really good question, Kripa. So for now, let me just park your question aside. We will be extensively discussing about functions towards the later part of this session. So that time, in case if you're not clear, we'll come back to your question and I'll help you understand it better. Is that okay, Kripa? All right. So moving forward, let's start deep diving into the Java world by first understanding the various data types in Java. So there are mainly 4 different primitive data types that are present in Java. You have integer, you have float, you have character, and then you have boolean. Now, it's essential to have different data types present in Java because you can't have a single data type that stores all the values. It becomes a problem to allocate memory as well as process it from the machine side. So for that, what we have done is that we have divided into 4 different primitive data types, and each of these 4 primitive data types have a sub data type as such. So when we talk about integer, there are mainly 4 different types. You have short, you have long, then you have byte and int. In float you have double and float, and in character you just have character and boolean. Now you may be wondering why we have different subtypes under both float and integer. So let me help you understand that with a table. Now when you talk about a byte actually uses just 1 byte of memory, but the value that it can store is only between -128 to +127. So only if a number is between this range can you use a byte data type to store it. So in case if you store a number that is greater than this range inside a byte value, it does not store it correctly. Then comes your short. Short actually stores between -32,768 to +32,767. After that comes your int. Now int is a standard type that we will be using for all the integer values. So int actually stores a value that is in between the range -210 crores 47 lakhs all the way till +210 crores 47 lakhs. When you look at long, it stores even a greater value, but again the memory used is higher. So long actually uses double the memory when you compare to int. So standardly we'll be using int as for storing integer values. After that you have float and double. Now float and double are actually used to store numerical values that have an associated decimal pointed values. So let's say if you want to store 3.15, then you need to use a float and you cannot use an integer. Finally, you have char that is used to store a character value. Now, every character that you store inside char is actually translated to an integer value and stored inside it. Now, this integer value actually denotes the corresponding equivalent value of that character as per ASCII terms. Now, ASCII is a standardized table that helps you understand the equivalent of every character to an integer value. And finally, you have Boolean that uses only 1 bit of memory that stores either true or false. So basically your Boolean either stores 0 or 1. So let me show you how to declare a variable as well as how to use a data type. Since we're back on our Eclipse, let me show you how to declare a variable. So always first begin by the data type. So let's say you want to store an integer data type, let's say int num1, and then you can put a semicolon and end it. Similarly for float num2 and end it. So again, if you want to declare multiple variables of the same data type, then all you need to do is go back to the data type declaration, put a comma, and then specify the name of the variable. num3. So this is how you declare multiple variables of a same data type. Apart from this, let's say when you're declaring the variable itself, you want it to have a default value as such. So that is actually called initialization while declaration. So in that case, what you can do is that you can put a single equal to operator and then specify the value that it should have while creating itself. So here what basically happens is that variable num1 is created with the default value of 10. So this is initialization while declaration. Apart from this, once you have declared your variable, anywhere in the program you can go ahead and assign its corresponding value. So num2 is going to have 15.56782, and always end your statements with semicolon. This helps Java to understand that you're ending your statement. Now rather than using float, what we actually prefer is to use double, because this is more precise as such. So you can change float to double. So here when you're using a double, it mainly concentrates more on your precision than your memory management. So now that you are familiar with respect to the different data types, it's always important to use the correct data type for the correct value. You always need to be aware of how much memory your variables are going to be using. So even though Java takes care of it, a good programmer always concentrates on these small things. So again, when you look at character, let's say char x. Now char x should have a corresponding equal value, so I'm going to put quotes and let's say x. So a character variable can store only a single character. This could be your alphabets, it could be your numbers, it could also be your special characters as well. But always remember, you need to store it inside quotes. Now let me show you something. Let me remove this quote and let me store an integer value here, let's say 100. Okay, now this is not an error, but let's see what prints out. I'm going to print x. That is, if you want to print a variable directly, all you need to do is specify the name of that variable. So right click, so before that save your code, right click and run it. So I had stored 100, but can someone tell me why I'm getting the output as D? That's right, Adam. This 100 is the ASCII equivalent of D. So you have a long list of ASCII character equivalent. Let me just show you that. So this is your complete ASCII table. So if you look here, 100 is the corresponding equivalent for the character D. Similarly, you have a complete list here. So this is something that you can refer in case you're not clear. Okay? Alright. And finally, I think we have left out with Boolean. So let me show you how to declare Boolean. Boolean, then let's say B equivalent to. So again, as I had told, a Boolean takes a value either true or false. So in case if you want true, it's true, or let's say false, that's false. Now again, one thing you need to remember is that true and false are actually keywords in Java. So anything that you see highlighted here, they are keywords. That is, they already have a reserved meaning in Java as such. So you cannot create variables with the same name as the keyword. So always remember that when you're working with Java. Alright, so any doubts with respect to the various data types in Java? Okay, so Mayank is clear, so is Adam, Anjali is also clear, Kripa, Arun, Scott, that's great to see, guys. So now that we have talked about the various data types in Java, let's move forward and discuss the various data operators in Java. So there are basically 4 different operators in Java. You have your arithmetic operator, you have your unary operator, relational operator, and logical operator. So don't worry, we'll be discussing extensively about each one of them. Let's start off with an arithmetic operator. Now your arithmetic operators are quite straightforward. You have your addition, that is 2 plus 3 gives you 5. When you have a subtraction, again 3 minus 1 gives you 2. Multiplication again is 2 into 3 gives you 6. And division is again straightforward, 6 divided by 3 gives you 2. Now to those who are not familiar with any of the programming languages, the modulo division may be new to them. So here it's quite similar to your division itself, but the difference here is that when you divide rather than getting the quotient, what you get is the remainder here. So when you modulo divide 5 by 3, then you get the remainder as 2. So let me just give you a simple explanation here. So let me just clear all this. So let's first begin by declaring 2 integer values. Let's say int num1 equal to 20, and then let's say num2 equal to 5. Okay, so I'm going to perform set of operations. So what I'll do is I'll directly print it out. So let's say sys out num1 plus num2. Okay, so just save it. If you run it, you can see the output as 25. So 20 plus 5. Similarly, let me just copy this. So you have here subtraction, then let's say multiplication, and then let me just add a division as well. So if you save it and run it, so you have 20 plus 5, that is giving you 25, 20 minus 5 is 15, 20 into 5 is 100, and 20 divided by 5 is 4. So to this, what I'm going to do is that I'm going to declare another variable, let's say num3 equal to 21. Okay, so I'll just rewrite this. Num3 modulo divide. Modulo divide is denoted by percentage divided by num2. Okay, so let me save it, and if I run this, who can guess the correct answer? Alright, so most of you have guessed the right answer. Let's check it. The answer for modulo division is 1 because the remainder is 1. So with this, I'm sure every one of you are clear with respect to the arithmetic operators. So let's move forward and talk about the unary operator. Now, the unary operator is a simple operator. What it basically does is that it either increases the present value of a variable by 1 or it decrements the current value by 1. But there are basically 2 ways how this processes. So you have pre-increment and you have post-increment. In case of a post-increment, what happens is that you first use the variable and then you increment the value. But in pre-increment, what happens is you increment the value first and then you use the variable. Now, you may not be clear with this, so what I'm going to do is let's go back to our Eclipse. What I'll do is I'll remove all this. Let's say sys out. So I'm going to say num1 plus plus. Okay. I'll copy the same. And here what I'll do is instead of this, I'll print plus plus num1. Okay, so let's just save this and I'm going to run it. So here you're getting the value as 20 and 22. Okay, so for those of you who are not clear, what I'm going to do is let me write comments here itself so that you can relate. Now to write a single line comment, all you can do is use double slash and everything written after that is considered to be a single line comment. So here the value of my num1 when I'm printing is equal to 20. So this is post increment where you first use the value and then you increment. Now once I have printed it, then what happens is that the value gets changed to your num1 becomes 21. But this operation happens only after printing. But if you take the same case for the next line, okay, so here what happens is the value, the incoming value itself for num1 is 21. Okay, so at this point I'm starting off with 21. But what am I doing here? I'm pre-incrementing. That is, before I print itself, I'm going to increment the value. So it gets changed to 22 and then it gets printed. So I hope with this you guys are clear with respect to how pre-increment and post-increment works. Similarly, your decrement is also quite straightforward. Let's say minus minus. If you save it and run it, you can see here again it is 20 that gets changed here to 19. And then when you have this 19, you're using pre-increment. So here you have 19 and then pre-decrement works. So again 19 gets reduced by one more and it becomes 18. So with this I hope you guys are clear with respect to both how unary operator increment and decrement works. Okay, so moving on to the next operator, you have your relational operator. Now your relational operators are quite straightforward. You have lesser than, greater than, equal to and not equal to. Apart from this, you can also combine your lesser than, greater than with equal to. So you can have lesser than or equal to, greater than or equal to, apart from your lesser than and greater than. So again, if 2 is greater than 3, but that's not true, so you get the output as false. Similarly, is 2 less than 3, it's true. Is 2 equal to 2, that's true. So always when you're working with relational operators, your output is a Boolean value. Always remember that. So let me just show you that. Let's say num3 greater than num2. Okay, and here let's say num1 equal to say num3. Okay, so as I said, you're going to be getting Boolean values as output. So if you run this, you can see the first statement is true. That is, your num3 is greater than num2. Obviously 21 is greater than 5. But when you look at the second statement, is num1 equal to num2? It's not equal to, because num1 is 20 and num2 is 21. So I hope you guys can understand with respect to how it is. So again, let me say greater than equal to, and I'll change value of num2 to 21 itself. If you run this, it says it is true. But if I remove the equal to sign from here and save it, then you can see it is giving me the value as false. So here basically you're combining two operators itself. It can be either lesser than or equal to. Okay, so I hope with this you guys are clear with respect to the relational operators. Okay, that's a really good question. So I have a question here from Kripa again. So Kripa has asked me, where will unary operators and relational operators will be used? So Kripa, unary operators, they will be used when you're keeping a count of something. So we have this concept of loops in Java, where you're going to execute a certain number of statements multiple times. So that time, to keep track of how many times you're executing the statement, your unary operators come into picture. So your relational operators are something that you will be using when you need to either compare or check the values of two operands as such. Once you've met the condition, then a certain set of statements will be executed. Now another control state that we'll be discussing in the next session is the if-else statement. So then let's say if you go back to our variable, let's say if num3 is greater than num2, then what I'm going to do is I'm going to write num3 plus num2. So in those conditional statements, that is when you need to meet a specific condition, then you're going to be using the relational operators extensively. Okay. All right. So moving forward to the last operator, that is your logical operator. Now there are mainly three logical operators. You have and, or, and not. So again, your logical operators are going to be used in your conditional statements extensively when you're checking multiple conditions as such. So again, if you look at your previous statement where your relational operators give you Boolean outputs, then if you have multiple conditions, then you're working with multiple Boolean values. So in those cases, your logical operator helps you make the right decision. Now in case of a logical AND, only if the value of both X and Y is true, then will you get the output to be true. Otherwise, it will give you a false value. But at the same time, when you look at the logical OR operator, if either at least one of them, that is either X or Y, is true, then the value is true, else it is false. Okay. And finally, you have your NOT operator that gives you true if X value is false, and it gives you true if the value of X is false. So basically it inverts the current value of X. So what I'm going to do is that I'm going to change all this. Let's remove this. Let's say true and false. Okay, so basically I'm performing a logical AND here. So I'll just copy this and I'll show you all the four possible variations with respect to AND operator. So let me change it to false and false. I'll change it to false and true. And finally I'll make it true and true. So if you save it, let's see the output. So you can see every statement where both my operators were not true has been considered to be false. So this is how your logical AND works. So if you take the same case for logical OR, now again to change, all you need to do is for OR it's straight pipes. Save it. Let me just show you how the output looks like. So you have here, when you look at the same statement, it gives you true wherever you have at least one statement to be true. So only in my second case where I'm working with false and false does it give me the output to be false. And finally you have your NOT operator. Let's say, now again for NOT you're going to be using the exclamation operator, NOT of true. You save it. This does not give you a corresponding. So finally, once you've saved it, right click and execute it. So you can see when I'm taking NOT of true, it is giving me a false value. So with this we come to a conclusion with respect to the various data operators. So any questions still here? Okay, Mayank is clear, so is Adam, Scott, Vivek, Anjali, Kripa, Aaron. That's great to see, guys. So again, I'd like to remind you at any point if you're not clear, do let me know so that I'll be able to assist you. Now I hope you guys are simultaneously trying out these operators while I am explaining it to you so that you get a complete learning experience. So at any place, if you faced any troubles or you're not clear at any syntax, do let me know. I'll be able to assist you. Alright, so now that all of you have successfully executed these codes, let's move forward to the next topic, that is functions in Java. Now this is a very important as well as a very strong fundamental topic, so please pay your complete attention here. Now, what is a function? A function basically is an organized block where you're going to be writing a set of reusable instructions. That is, let's say you want to perform a specific operation multiple number of times in your program. So to give you an example here, let's say I want to perform an operation here. Let's say I want to compute the area of a circle. So rather than writing it multiple times in my code and increasing the redundancy of my code, what I'm going to do is that I'm going to put it inside a function. Now whenever I want to compute the value of the area of a circle, I'll just call the function and pass its corresponding values. The function will calculate it. Now through this, mainly two things are achieved. First is that my code redundancy reduces. Apart from that, my code's performance also increases. And it completely decomposes my process procedurally. Now, there are basically two types of functions that we will be working around with. The first is your built-in functions that is already present in Java, and the second is a user-defined functions, that is we will be writing a function to meet our requirements. Now there are several built-in functions present in Java. Your system.out.println is in itself a good example of this. So your print statement is actually a built-in function in Java which you're using here. Okay? Alright. Now this is basically a structure of a user-defined function. You're going to be specifying modifier, that is, it will either be public, static. Now don't worry about this, we'll be extensively talking about our specifiers in the next session, but for now just remember you're going to specify a modifier. It could be public, it could be private, or it could be protected. And then the return type, that is, what kind of data type is my function going to return. Now in case it's an area function itself, it's going to give me a double value. So here I'm going to specify double. Okay, and then you're going to specify the name of the method. So again, going back to our circle area, I can call it circle area and the parameters. So for computing area, all you need is the radius. Once I have that, I can write the statement here 2πr and then I can execute it. So this basically is an example to add two numerical values. You're calling public, static, int add, and this function is taking two arguments. When I say arguments, these are basically inputs that you're giving to the functions. So it is taking int a and int b, then you're creating a new variable int result that is computing a plus b, and it is returning the result. Now this result is of a type int. So again, I have specified my return type as int here as well. Now if you look at the complete structure here itself for the addition program, you start off with java.util, that is importing a package. Then you come inside your main class, you have your add function which is taking two arguments, that is for your function parameters. Okay, so this first statement, this basically is also referred to as your function definition. So if anyone asks you what is function definition or function prototyping, it basically means that you're specifying the modifier, the return type, the name of the function, as well as the parameter it takes. You don't have to tell them the complete definition, but this is basically the function prototype. After that, if you go inside, it's the same set of statements. You're creating a new variable int result. Result is equal to a plus b, and you're returning this result. Now when you come down to your main program, so int xy, and I'm going to store an output variable. So what I'll do is I'll just execute this program directly so that you can understand it better. So let's begin by creating a new class. Just click on the class icon present here. Let me call it function test. I'll include a main function as well. So in case if you're not able to see the finish option, that basically means that you have not specified your source folder. So once you click on source, you can see the different projects. So we're working with Java training, so click on OK and then click on the source inside Java training folder. Once you've done that, you can click on finish and then you have a new class function test. So let me start by first writing the code, and simultaneously I'll be explaining you what it works for. So let's say I'm going to create a new function that multiplies two variables. So let's say public static int mult that takes int a comma int b. Okay, so basically I'm taking two variables and then I'm multiplying them. If you want, you can put in another, let's say int c. Always make sure you pass the correct number of arguments to the function. Okay, so I'm going to create a new variable, let's say int result again, then my result is going to be equal to a star b star c. Okay, so basically I'm multiplying these three variables and then storing into result. After that you have your return statement. Now since my function has to give me the output, you're going to specify return result. That is, the value that you have computed here by multiplying has to be returned to whoever is calling that function. It's only because they need the output of this that they're calling this function. So that value has to be returned to the calling function. Okay, now in your main function you have int x comma y comma z. That is three inputs that I'm going to take. And then I need one more variable, let's say opt. Opt is going to store my output that is going to be returned from my multiplication function. Now comes the part where you have to take the input from the user. Now to take the input from the user, what you're going to do is there are two major steps that you need to follow. First is you need to import a package that is java.util. Now to do that, just follow the same syntax, import java.util. Now I'm going to import all the classes present there. So dot star, that is, it includes all the classes present inside java.util package. and then put a semicolon at the end of it. So always remember to put a semicolon even at the end of a import statement. Now the next part is you need to create an object here. The next thing that you need to do is that you need to create a new input object, that is an object inside which you're going to store your input. So just follow the same syntax, scanner, let's say inp equal to new scanner system.in. Okay, so this is a standardized syntax for whenever you want to take input from the user. So you need to always first add the statement that is import java.util, and then you need to create scanner, then you need to create a new object of scanner type. So this is basically how you create a new object, that is you specify the class to which that object belongs to, the name of the object, and then the new keyword. Okay, so then I need to take the input from the user. Let's say I'm going to ask him. Now if you want to print a string as the output, always put it inside double quotes. So when you do that, it prints the output as a string. So let's say enter the value of x, and then comes my third statement of taking input. My x variable is equal to your object inp dot. You're going to take an input variable as your input. So next int int. Okay. Now what this basically means is the next input provided by the user of integer type should be stored inside x. Okay, so always remember there are three statements for taking input from the user. You need to first include java.util, then you need to create a new object from scanner class, and then this is how you take the input from the user. Okay, so I need to take three variables, so I'm going to copy this. So first I have taken x, so next I need y, and then I need z. So I'm going to change it here as well. So here I have taken the input from the user for the values of x, y, and z. Now it's time I call the function which is going to multiply these three values. So that is quite straightforward. All you need to do is specify the name of the function and then give the corresponding arguments to that function. So in this case it's x, y, and z. Now I told you it's going to return a specific value, that is it's going to give me the output. So that has to be stored inside a different variable. So opt is going to store my output of multiplication. And finally we can print the output of opt. So here let's say if you want to print a string along with a variable, so then it's quite straightforward. Bring in quotes. Let's say output is, close the quotes, and then put a plus statement. So basically a plus is used for concatenation. Now don't get confused about this. This is how you print a string along with a variable. We'll be extensively talking about strings as well in the next session. Alright, so just save this, and then it's time to run this code. So right click on the workspace and select run as option. So first thing it's asking me value of x. So let's say 25, asking value of y, let's say 4, and asking me the value of z. So I'll say 8. So 25 into 4 into 8. The output is 800. Okay. So I hope with this you guys are clear on how to take an input as well as how to work with functions in Java. Can you guys give me a quick confirmation in the chat box? Alright, so I've got a confirmation from everyone. It's great to see that you guys are following till here. So now that we have completed our discussion on functions in Java as well, it's time to help you understand the various object-oriented programming concepts in Java. Now here comes your first and major concern, that is what is an object. So basically an object is a collection of both data and methods. Now these methods or functions as such actually work with respect to those data. So let's say your mobile phone is an object, then it's going to have a state of color, that is it's going to have a specific color, it's going to have a specific dimension, and it's going to even have a specific shape as such. So this is something that is unique to that object. It's also going to have certain behaviors, that is it's going to turn on or turn off, it's going to help you make calls as well as manage different messages. So these are basically my functions as such. So everything in the real world that you see can be considered to be an object, and it can belong to a corresponding class. So this is basically a phone. Now this phone actually belongs to a class that is of phone itself. Now I can have different objects that belong to the same class, but they may have specific unique values as such. So basically my class is a blueprint from which my various objects are created. So all my phones are going to have a specific brand, they're going to have a specific battery power, it's going to have a specific processor as such. So a class basically defines a certain set of common elements, common states or data that each of the object is going to have, and also define a specific behavior that all of these will have. Now all of these are going to have a specific brand name. So you have an iPhone, you have your Nokia's newest phone, you have Samsung, you have Google Pixel. They all are actually objects from my class phone. Similarly, they're going to have a specific value for their battery power. Each of them are going to use a different processor as well. So the value that each of them are going to have, that is unique to the object. But they're definitely going to have a processor, they're definitely going to have a brand. All this basically is a blueprint as to these objects. So are you guys clear with respect to what is an object and what is a class? Alright. So there are mainly four key concepts when you talk about object-oriented programming. Now the first concept that we're going to be talking about is inheritance. Now inheritance basically is a mechanism through which one object can acquire the properties and behavior of its parent. Now if you look at the same example, I have a parent class or a super class known as mobile, and I have three child classes. One is Apple, one is Samsung, and one is Google. Okay, so these are basically classes as such. So I have an Apple class that inherits properties from mobile, Samsung that inherits properties from mobile, as well as Google that inherits properties from mobile class. Now in all of my three classes, I'm going to have these three same operations present. That is, it's going to have a brand, it's going to have a battery power, it's going to have a processor. Now Apple could have subsidiary companies, so my brand value could change. Not all the phones that is released by Apple have the same processor, nor do they have the same battery power. So then again they change. But all these properties that were present in mobile has been inherited specifically in my Apple. Similarly is the case with Samsung as well as Google. So rather than having to define these properties again in my class, I can directly inherit it from a superclass. So I hope with this you guys are clear with respect to how inheritance works. Alright, so next comes our key concept that is known as encapsulation. Now, when we talk about encapsulation, it is basically a process in which you're going to bind both your code and data together. So here if you look at the example here, what is happening here is that each phone actually selects from one of the different towers and then optimizes your connectivity. Now each phone actually has a different logic to achieve it, and this is not something that is known to you. So through encapsulation, what you're doing is you're achieving a data hiding, as in you're not letting others know how you're selecting the tower, but you're achieving the best optimal option here. So you may have three different towers, you may choose only the closest one which is most efficient, but how it is chosen we do not know. So here you are hiding the data. So I hope with this you guys have got an understanding of how encapsulation works. Alright, so the next key concept is polymorphism. Now polymorphism basically is the ability of a variable or a function or even an object to take multiple forms. Now there are mainly two types of polymorphism that happen. You have runtime polymorphism and you have compile time polymorphism. Now we'll be extensively talking about that in the next session as well. But for now, if you look at the example here, my mobile acts as a camera, it also acts as a remote, and even acts as an MP3 player. Apart from this, there are different features, but when I require, my mobile goes on to take multiple forms as such. So I hope this example is something that you can relate to. Alright, definitely. So the final concept of object-oriented programming is your abstraction. Now abstraction basically is a methodology of hiding the implementation details but only providing the functionality to the user. That is, if you look at the same example here, when you get a call, do you know how the call is generated on your phone? We don't. All we see is the notification that one of our friends is calling us. But there's a huge code that is written on how to manage the call, how to display the call, but we are not quite aware of it. But as long as we get our notification, we are happy. So what we're doing is that we are hiding the implementation details, but we are only showing the details that is needed to the user. So with this, we've come to a conclusion of the 4 object-oriented concepts. Any questions with respect to these concepts? Okay, so Scott has a question here. Scott is asking me, how is encapsulation different from abstraction? So again, Scott, to answer your question, I'll just give you a simple definition. So when you talk about abstraction, you're basically hiding the unwanted details from the user and providing them only the basic details that they want. But when you come down to encapsulation, there you're hiding both the code as well as data into a single unit and you're protecting it from the outer world. So that is not something that anyone else can directly access as well. I hope that clears your doubt, Scott. Alright, so with that, let's summarize what we've learned today. We started off with an introduction to Java, then we moved on to discuss the various features of Java. After that, we saw the Java environment, the JDK, JRE and JVM, and then you understood how a Java code works. We even tried out various programs in Java, and then we talked about the different data types in Java. Moving forward from there, you saw the different data operators in Java, and finally we talked about functions and object-oriented concepts in Java. So any questions with respect to today's session? Any concepts that you're not clear that you want me to repeat? Okay, Anjali says no, Krupa says no, Mayank says nope, Adam says great session, thank you Adam, Scott is also clear, Aaron and Vivek both, okay, that's great to hear guys. So with that, I will be sending you the notes for today's session as well as an assignment that you need to complete before you come into the next session. Hope you have a great weekend. Goodbye.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!